The next thing that I want to talk about is even and odd functions. So this is different than an even degreed function or an odd degreed function. An even degreed function is required to have an even function, but that's not the only requirement. So let's take a look at even functions. They have to be symmetric about the y-axis to be considered even. They can be even degree and still not be an even function. So we have to have symmetry about the y-axis. This has to be a mirror image. So if we have a mirror image across the y-axis, or the y-axis is an axis of symmetry, then we have an even function. In order to have an odd function, we have to be symmetric about the origin. So what that means is that we have 180 degree rotational symmetry. So in other words, we're going through the origin, and any point that we can pick out on the graph, if I rotate 180 degrees exactly, I land back on the graph. So it's 180 degree rotational symmetry, and it is required that it must go through the origin. If those conditions aren't met, going through the origin first and then this rotational symmetry, then it can still be an odd degreed function, but it's not overall an odd function. We have 3 examples here. Don't worry if your example numbers are different than mine. There's a couple different versions of this foldable. And so on these examples, we want to sketch each graph and determine whether the function is even, odd, or neither. So I'm actually going to go ahead and take all 3 of these functions and plot them in Desmos so that we can get a little bit of an idea of what they look like. And while we're in Desmos, we're going to go ahead and decide if we are odd, even, or neither, and then we'll come back here and record our information in our notes. Let's take a look at our first example. Our first example was x to the third minus 7x. Notice that it does go through the origin, and it is an odd degreed function, so it has the chance of being overall an odd function. But in order to determine that, I need to see if I have some points that are rotated 180 degrees. I see that I have the point 2.646, 0, and I have a negative one that is rotated 180 degrees there. I can also take a look at my high point here and my low point here and notice that those are 180 degrees from each other. So that means that we do have an odd function. Let's move on to our next one, x to the fourth plus x squared plus 1. And I see that it looks symmetric about the y-axis. I have a y-intercept here, and I can see that if I pick out a point, let's say 1, 3, somewhere close to there, and I have a negative 1, 3, the same thing. So this is even. It is even degreed, but we can go further and say that it's an even function because it has symmetry about the y-axis. Finally, x to the third plus 2. This is an odd degreed function, so it has the potential to be an odd function overall. However, it does not go through the origin. The y-intercept is at 2 instead of at 0. We can say that this is not an odd function. It has no chance of being an even function. It would have to be symmetric about the y-axis for that and be an even degree overall. So let's go ahead and go back to our notes and record this information. We decided that number 3 was odd because it went through the origin and it looked something like this. This isn't perfect, but you get the idea. Just a really rough sketch of what it was looking like. Our second one we decided was even. It kind of looked like a little bit flattened parabola, so a little flatter at the bottom than normal, and it was symmetric about the y-axis, so it was even. Our last one was neither, and the way that I knew that right away was that my y-intercept was not at the origin. Remember, it has to go through the origin in order to be an odd function, and this one is definitely not symmetric about the y-axis to be an even function because it is an odd degree. So even, odd, or neither. Before we move to our next topic, I want to do one more thing. Remember that I said we would come back to this after we talked about even and odd functions. So now that we've done that, let's take a look here. I see that I have an odd degreed function here because I have arrows that would point in opposite directions. However, I notice that I do not have a graph that goes through 0, and if it doesn't go through 0, it cannot be an odd function overall. So we would say that this is neither.